Yeah, so I realized that JSConf was sold out, and I panicked, and I thought, oh crap, the only way I'm actually going to get to go is I've got to propose some kind of talk. And in all my panic, I came up with the most ridiculously crap name for a talk ever. So I'm going to have to change that. I want something really respectable, something that might get me a book deal, you know, something really solid. So instead of PIMP your JS library, the new name for the talk is Designing Non-Shit APIs with JavaScript. So I'm going to start at the beginning. In the beginning, I say the beginning, the real beginning of JavaScript, it was all Netscape 4.6, i.e. 4.5 for Mac, you know, it was Babylon. So let's ignore that whole stage and start when things actually became, where the community started to organize itself. It started to organize itself around these sort of three main libraries, Prototype, Dojo, and one that is still around but doesn't get mentioned very often, MochiKit. They all had their strengths and weaknesses. Prototype was probably the most popular, at least around this time, about 2004, 2005. It was a good general purpose library. It shipped with Ruby on Rails. Dojo had been around in sort of several forms for a really long time by that point, so it probably still is, but was then the most fully featured and probably most advanced in terms of functionality. And then MochiKit just had some really interesting ideas, such as the concept of deferreds, which has only just made it into jQuery now. But then this newcomer came along, and I remember sort of, you know, this turned up on Ajaxian one day, it clicked through, and it was a really simple site, and sort of right front and center was this code example. And I think I'm probably not the only person in this room that as soon as they saw this, it kind of changed things for them. And I think, you know, we all know what happened next. It went from 0 to everything. It has had this sort of skyrocketing growth, and almost has got to the point now where it's almost the default choice of library for browser programming. So what I want to look at is sort of why did that happen? Well, at least initially, jQuery from the internals was not actually that sort of important. It was a lot of cobbled together things. So it had Dean Edwards event utilities. It had Simon Willison's selector engine and a load of other stuff that was just sort of cobbled together. But what made it really, really important and what was responsible for the explosive growth is that John had created this amazing interface. And you could just imagine that when he was designing this, he didn't design what it was going to do, he designed how he was going to do it before starting even writing the code. And I sort of want to sort of make you think about that the fact that as programmers, we're all designers. We're designers of the API, of the code that we write. And it's one of the most important things that we need to think about. It's what John thought about as the #1 priority, and it's what made jQuery and several other pieces of software really, really successful. And we should be thinking about this every time we write some code. There's 3 things I'm going to discuss which I think make really good, usable APIs. Predictability, simplicity, and flexibility. So we'll dig in to the first one. Predictability. When I'm thinking about this, I think of, you know, when you were a kid and it was Christmas Day, you run into the lounge to get your presents, you rip open the box, it's like a transformer that you've always wanted. Rip open the box, really excited to get it out and start playing with it. But what you're actually greeted with is a very complex looking manual and stuff in loads of different parts. And you can't play with it immediately, so I'm sure many of you are like me when I was that age. I just immediately thought, I don't know what to do with this, and, like, handed it over to my dad, made him work it out, while I ran off to the other side of the room with the box and made a robot outfit. And I think as developers, when we're actually sort of choosing to solve a higher order problem, we don't want to have to think about how the smaller things work, which is why we go seeking libraries. And we want to be able to make our libraries as predictable as possible, so as soon as the developer looks at the code, and they can almost infer how it works rather than have to spend all of this time digging through the documentation. So how do we get to this sort of level of being predictable? Well, you need to think about your audience like you do with any design task. The audience in our case is really easy. We know the audience really well. It's all the JavaScript programmers. And that means we can infer a lot about what our audience knows about, and we can use those conventions within our code to kind of add that familiarity. The first port of call you can go to is the actual conventions that exist within the library, the language itself, and the standard library. So you can, if we're writing a JavaScript library, you can pretty much always be sure that this person knows JavaScript and has worked with the standard library. So definitely, stick with that and just get this bonus predictability. Who snake cases their code in the room? Does anyone? No? That's good. I was going to ask the person next to you to slap you. I think you see a lot of code from time to time that doesn't use Camelcase. JavaScript should always be Camelcase. The standard library is Camelcased. It's definitely something that there should be no debate about at this point. So first off, really easy, don't deviate from Camelcase. And also, adopt all of the other conventions that come from the standard library. Constructors should start with uppercase, and so on. Now, one thing that you sort of might think would be a good idea to sort of gain a sort of level of predictability, and probably is good from this point of view, is you might want to actually start by kind of polyfilling missing functionality like we heard about yesterday. I'm not outright against that, but all I would like to say about it is be careful with that. Firstly, for the reasons that Andrew pointed out, your little library that solves a certain problem isn't the right place to fix array for each. There should be, if it's going to be done anywhere, it should be a lower level library. But also, I think you start to get into this situation where you can surprise developers. It's pretty easy to write what you think is a polyfill that fixes some missing functionality, but it works in quite a different way from the real functionality that you're polyfilling. Even in like a small way, for instance, if the native thing will return like a live node list where new nodes will appear in it, and then your polyfill just returns an array, you've got that slightly different behavior, which introduces a whole level of unpredictability. Another place you can go to sort of seek conventions that you can rely upon is popular libraries. Talked before about how ubiquitous jQuery is. I think even if you're not a jQuery guy, you can almost you're familiar with how it works, and so we can use that, and we can use conventions from other popular libraries depending on the domain you're in. So, for instance, I think a really nice example of this is Raphael. Raphael has got really popular really quickly. And it's just incredibly easy to use. You're sort of there doing stuff with it within minutes of just arriving on the site and seeing one or two code examples. One of the nice things that it does to kind of add this predictability is it doesn't try to make new names up for things. So if you want to set an attribute, then it's got a very similar method to jQuery. It just acts exactly like jQuery. So if you're a jQuery programmer, you don't ever have to look this method up. It's just the same as what you already know. And similarly, it adds a load of others that adopt jQuery conventions. And it's just sort of less mental overhead for the programmer. We have show and hide and various other things in there. Another area you can go to is the problem domain. If you're trying to tackle a certain problem, or your library is dealing with a certain thing like HTTP or maybe CSS, you can basically model your API around that and use some of the conventions from it and get this kind of added level of predictability. A really nice example of that is the jQuery's CSS manipulation. So you can see here that there's such a large amount of mapping between how you would manipulate jQuery, CSS in jQuery as how you would actually write a CSS declaration, that you're never going to have to look at the documents to work out how to do this. You almost infer how that works. So to start putting a few of these ideas into practice, we'll start an example. The example is going to be a DOM builder. It's kind of an interesting problem to tackle from an API point of view, because everything that you get given in JavaScript to do this is pretty raw. You've obviously got the inner HTML way. That's kind of pretty ugly, especially when you start interpolating loads of variables, because JavaScript's not that good at working with strings, so you just end up with a mess of pluses and quotes. And then even worse, you've got the DOM API, which you can barely do anything useful with in its raw form like this. So it's definitely something that needs masking. So we'll try and create a nice API around creating DOM nodes. So the first thing to do is we'll just create the nuts and bolts of this thing. We'll have this function called element, takes name, it takes an object with the attributes for that node, and it takes an array of children and does the very basic thing. Obviously, there's a lot of optimizations you could do on this, but this is just, simplest possible for clarity. It just creates that node, sets the attributes, append childs the children, and then returns that node. So if you want to use that code, this is our first pass. It looks something like this. I've tried to kind of creatively indent it to make it make a little bit of sense, but as you can see in its raw state, it doesn't really map to our problem domain. It doesn't look like HTML. Let's try and make it look like HTML. So, thinking about the API, we'll come up with something like this, where instead of having this single method called element, we'll create a method for each element in the HTML spec. So we can do html.form. And you can already see that if we do that, then we're moving a lot closer to it actually looking like something like an HTML document. So how do we do that? Well, we can basically sort of layer a little bit of Java, of a sort of interface veneer on top of our basic element function. And this is how you do it. I don't think it's worth going through the code, and everything will be on SlideShare. But essentially, we create a function for every tag, and then it just creates a function that eventually calls html.element. And we've got like a little bit better there. Okay, so next up, simplicity. Now, from the sort of web design world, there was this really sort of classic book that I'm sure most of you heard of, many of you will have read, called Don't Make Me Think by Steve Krug. It's actually about creating interfaces for the UI, but I think the basic concepts in it you can directly apply to API design. The basic crux of it is don't make the user think about anything more than they necessarily have to get this solution done. Don't make them make decisions that they don't need to make, and don't confuse them with things that don't make sense to actually solving the problem in hand. And the problem with this is that if you do present all of these options in your API all of the time, you end up with like a very, very big, a very complex and very hard to remember API. And you end up forcing your users to read the manual over and over and over again because you've created something which is too big to fit in a programmer's brain. So we want to avoid this, and so the time-honored way of doing this is by the use of sensible defaults. You just decide on things that need to be optional, and just if an argument is the same way 90% of the time, then just don't show that option to the programmer at all unless they actually need it. This has obviously been exemplified by Rails that has had a long history of sensible defaults. Something that really needs some sensible defaults is this particularly laughably bad method from the DOM API. And it's just to create a mouse event that you can then dispatch on a certain element. But look at that argument list. I mean, how would you ever remember that? If you ever want to call this function, it's basically mandatory for you to go and look at this page. Similarly, if once you've used that and you have this thing lying around in your code, no one will know what the hell that stuff means. Zeros, falses, and nulls in some kind of arbitrary order. That could definitely do with tidying up. We don't need to make have the designer make those decisions. Another sort of less extreme example, but also annoying, and also from the DOM API, is the add event listener. We use it all the time. Or probably, well, I end up doing so because I don't can't use libraries most of the time. But it's fairly straightforward. You have the type of event, then you have a handler, which is your function, and then you have this hanging boolean on the end, and which tells which says whether you want to use capture or not. Now the thing is 99.9% of the time you don't want to use capture. So why do I have to worry about that and put false on the end? If you actually omit that false from the end, then you get an error. Why don't we just only let people specify true on the end if they need capture, and then otherwise don't worry about it? So let's go back to this really hideous example. What could we do if we were writing the DOM API, what could we do to make this in any way sensible? Well, a sort of well-adopted thing to do is use optional hashes for the optional arguments. There's definitely a few things that we need there. We need the event type, but then probably from that point on, all of the other arguments for keyboard modifiers and whether it's bubbles, whether it's cancelable, and so on, are all things that we don't really need to worry about for most cases. So why don't we wrap all of those up into a hash? So we'll have something like this, where the event type is required, so that's just a normal argument, and then put everything else inside a options hash. And this is something that it's bread and butter stuff. An interesting article came out the other day that Rebecca Murphy wrote, which is really well timed for me. She sort of asked around on Twitter about people's opinions on when options hashes were appropriate and when they weren't, and wrote up a really good article on it. So it kind of meant that I don't really need to talk about it, but this article is a great read for that, and it's worth just reading it through and thinking about it and formulating an opinion on it. Next up, function calls should read well. If you're trying to solve a problem, you normally have some kind of sentence in your head that describes what you want to do. For instance, I want to replace this node with another node. So when you're writing your APIs, you can gain some sort of memorability and simplicity by trying to map that. I'm not really talking about going over the top and going COBOL and AppleScript style and making it read like English, but there's definitely some gains you can get. So here's 3 examples of sort of doing the same thing. And to me, it's fairly obvious which one is the most memorable here. We've got the top one, which is from the DOM API again. I'm trying to pick examples that are from the DOM API because I'm assuming that no one's here who worked on that to get offended. But so the DOM API has probably the least intuitive thing here that probably annoys a lot of us on a regular basis, where there isn't a replace method on the node itself. You have to go to its parent node, and then you have to pass in the new node and then the old node. But really what you're thinking in your head is, I want to replace old node with new node. So the method order there is the thing that really gets me, and it's just counterintuitive. and which leads me to look at the documentation for that method far more times. I kind of end up double bluffing myself and thinking, I know that it's the wrong way around to how I think it should be, but then I get used to it being that way around, and then I think it's swapped back, and I get in a mess. Dojo has kind of got the middle ground. It's in Dojo style, it's the way that you achieve these kind of things is a sort of much more generic, powerful method called place that enables you to place a new element in relation to a reference element in all kinds of different ways. So it again is like, I would say that the place method is a little bit too generic to be easily noticeable. You're thinking replace in your head, and then you have to find place. But I'm sure that's not too much of a problem. Again, though, it's suffering from an unusual sort of argument ordering here. It's new node and old node again. And then the last argument, which is the verb, is right at the end. So it doesn't read anything like replace old node with new node. It's kind of in reverse. And then jQuery, obviously, I think got this really right because it just reads so well. Old node, replace with new node. You just get that simplicity and predictability. Another thing you can try, and this is possibly on the side of dangerous, but works in some cases, is try and mask a little bit of the complexity that sort of is within the nuts and bolts of your library from the actual API user. This is, often kind of leads you down the path of magic, and magic can often be a bad thing because it introduces all kinds of uncertainty into the code. But in some cases, if you think about how your interface is going to work before you actually embark on solving the problem, you can come up with some really nice, simple things. An example is something we worked on at Twitter recently, which is a cross-domain communication library. It's basically all we do, is come up with various permutations of cross-domain communication libraries. But so we set about, before we even started writing the code, we set about just designing the API and writing code examples and getting a feel for how it might work. Before we even knew, whether we were going to use post message or whatever, just ignore that and get a text editor out and start writing the code. This is our first permutation. You sort of create a connection object, and then under the hood, we knew that an iframe would have to be created and several things would have to be initialized, and you have to wait for them all to load before the connection was ready to actually send a signal. So the obvious thing to do in that case is have connection fire a ready event, and then before you actually send any data over this connection, you just wait for the ready event, and then you can do your thing. But we looked at it and thought, yeah, that makes sense, but it's still sort of a little bit messy. What can we do to sort of clean that interaction up a little bit? So our second iteration was something like this, where we had a connect method that actually took a function which has the connection passed to it, and we only call that function when the infrastructure is set up. And that kind of reads quite nicely. But then we noticed that the calls we make across the cross-domain bridge are actually asynchronous anyway. So the developer is making a call and not expecting an answer back for some time in the future. So why are we introducing two levels of asynchronicity? Why can't we sort of factor that out in the API and simplify it? So what we finally came up with was something like this, where you get the connection object, and then you can immediately start calling methods on it. Under the hood, we actually just wait for the ready event and then call all of the calls that have happened, that have been queued up since then. And we sort of mask away that asynchronicity, which makes for a much nicer interface. And I think if we would have actually started writing the code for the nuts and bolts of the library before we designed the interface, we probably wouldn't have got here. But the fact that we were thinking about how it would be nice to use before we started, made a lot of difference in this case. Back to the DOM builder. This is how far we got last time, and we want to be able to simplify this. There's a few things in there that are just hanging around, and they're kind of line noise. So we want to simplify this. There's, for instance, if a node doesn't have any attributes, then you end up throwing in an empty object. If a node doesn't have any children, like the input tag, you end up having to always throw in an empty array for the children. And what we really want to do is clean all of that away so it looks more like this. And it starts to look a hell of a lot more. Oh, another thing that I forgot to point out is if you want to just put some text in, at the moment you'd have to do a document.create text element and have that inline, and that's kind of noisy as well. What we want to be able to do is get to this, something that's starting to look quite a lot like the actual DOM fragment that it's going to create, and just like move out all of that line noise and basically default some of the arguments. We can do that by actually changing the sort of API sugar function. We don't note we're still calling HTML element with the name, attributes, and children, so that remains solid. But we're actually using our we're veneering this sort of sugar layer on top of the solid base, and all of this code is basically examining the arguments array and the types that are in it, and basically sorting things out and making things much nicer. So, for instance, at the bottom, when we look through the children, and then if it's a string, then we know to do a document.create element on it. So then you're just passing a string in rather than having to worry about the DOM API at all. The final and probably most interesting part is sort of how do you build a library that remains flexible and allows and fulfills as many use cases as possible. And I suppose the comparison here is, and I think that this is the trajectory of nearly all open source projects, is they start out as something really lean and mean and a great idea. So we've got this penknife. It's got a knife in it, and it's also got a bottle opener. So what else do you need when you go camping? You can cut things, you can open cans. It's great. But then someone comes along and says, yeah, but wouldn't it be great if it had a compass and a toothpick? And and so you go, okay, yeah, I'll add a compass and a toothpick. That would be a good idea. And then so you're adding more and more things on. Then more and more pull requests come in, and they think, oh, yeah, but I've got all of these other ideas for features. Yeah, if you write your libraries in that way, then it can easily get way, way out of hand. And I think the thing is you need to always keep in mind that when you write a piece of code, you're never ever going to be able to please everyone. You shouldn't even try to second guess every use case, and you shouldn't even try to accommodate every use case and end up with this kind of bloated feature set. One pattern that you see a lot in lots of different libraries, and I think is kind of like a sort of an anti-pattern that leads to software bloat is actually with option hashes. Having an option hash as your only argument is not flexibility. Yes, you can add new properties, but it gets really out of hand. There's many libraries that I could have picked on for this. It's not so I'm not singling it out, but this is something from jQuery UI. And this is the documentation for the draggable component. It has 28 options. I mean, that's probably likely to grow, because everyone's going to go, oh yeah, but with my draggable object, I want to be able to do this and that. And if you look down, then they're for kind of niche cases like adding classes or being in a certain container. It's just all of the, people are coming with feature requests, and then the concrete features are built into this thing. What I would suggest is instead of doing that, you actually think about how you can add hackability into your code and your APIs so that you don't have to accommodate every single niche use, but you provide the framework with which people can sort of build their things on top. A really sort of first port of call thing that you could do to fix that is this idea of this kind of I think I first saw it in MERB actually, but the idea of there being a public API, an internal API that's still accessible, but you kind of suggest people don't mess with, and then a protected API which you just basically can't even get at. I think at the moment, especially since the module pattern has been around in JavaScript, you see a lot of stuff made private in JavaScript libraries that don't need to be, and then and once you've got truly private things, people just can't dig into there and actually do their own thing on top of it. So I suppose what I'm talking about is, in a sort of old school module pattern way, you've got your private methods that just exist in the closure that absolutely can't be messed with. I think I think it's best to try and keep those as a minimum, really, and probably only like really, really low-level stuff. But then the other thing you can do is have this idea of internal methods, and the convention that I stole from Webb is to underscore them. So they're there, and if you actually looked at this lib module, you'd see underscore whatever, and if you wanted to, if you really, really needed to, a developer could actually override that and change it and work with it. And then you've obviously got your public API. And you're basically saying to the contract with the programmer is, you shouldn't really mess with the underscore methods because they are internal and they'll probably change from version to version, so on your own head be it. But if you really, really need to, then it's there. A slightly more sort of complex, but a much, much nicer way to build in hackability is actually by using the fact that JavaScript has high-order functions. Wherever you accept a value for configuration, you can accept a function, and that adds this whole level of hackability straight away. A really sort of nice, simple example is comes from Ender, which is a library that's come out quite recently. They have this idea of they have this method called underscore select. And the contract is for that method that it takes a selector and a root node, and then it returns an array of matching nodes. Now, the cool thing about that is it comes with its own thing, like a limited selector engine. But it's really easy to just overwrite that function with a function that fulfills the same contract and uses Sizzle, and then you've got all of the extra jQuery style stuff in there. Or if you're using the same thing on a mobile platform, then all you need to do is override that, and then with something that just uses query selector all. So just them having this one function that allows you to overwrite it is sort of opened up this whole sort of sphere of possibilities in this code. And you can imagine this kind of technique can be used to add a really huge degree of hackability. Another way you can do it is by using inheritance. You can actually sort of use prototypal inheritance and build a set of base objects that basically map to the problems in your library, and then you can build on top of them with the core features. But then they're also there, and you can to expose to the to other developers to build their own features on top. Kind of a slightly more concrete example of that is in a library of mine called LoadRunner. LoadRunner is a dependency manager. And so the sort of central part of the library is this base constructor called dependency. And what you can do with that is all of the module loading and the script loading stuff is built on top of is a subclass of dependency, but then any other developer can make any other dependency on anything else they like, and all they have to do is create a new constructor that inherits from the base dependency and then override any bits that need to change. So in this case, it's we want to create a dependency on a mustache template being loaded. So we create this new constructor, inherit from dependency, and then all we have to do is override the start method, which is the method that kicks off fulfilling this dependency. And in there, we go and get the template, we parse it, and then we call complete, which is the other part of the contract. Once we've built this thing, we can use it at any place in the library where you can use a dependency. So at the bottom, there's a using function that says, I depend on this item, and then when it's done, then the results get passed in. And so this one thing that's sort of built into LoadRunner enables anyone to build pretty much any kind of dependency management on top of it. It doesn't have to be a script. It doesn't have to load over the network. It doesn't have to be anything in particular. A sort of lighter weight form of doing a similar thing is by using Duct typing, which I'm sure most of you have come across of, the idea that if an object fulfills a certain contract, it has a certain method, then we'll use that method implicitly. We can demonstrate that by adding a feature to the DOM builder. So what we do here in our element builder function is, what we want to say is, any object that has a toDOM method, then if it's there, we'll call that, expect it to return a DOM structure representing that object, and then we'll implicitly add it as a child. So we're just doing, type of the argument toDOM equals function, then we'll call that function, and that's going to be the child instead of the object itself, which allows us to write some really nice things. So here's an example. We've got an object which represents a tweet. All we need to do is add the toDOM method to it and use the node builder again to generate the DOM structure that represents a single tweet. And then we can just drop it in and say, if we had an array of those, then we drop that in as the child, in the child, and then it'll do all of the work for you. So suppose the crux of the matter is, when you're thinking about solving a problem, try not to write code to solve the problem. Think more about developing a set of tools that will enable you to solve that class of problem. And then once you've got these tools that sort of model the problem space, then you build your core features on top of that. The nice thing about that is, because you've built this sort of bag of tools for solving different things, you've basically made yourself a plugin framework just by designing your code in a certain way. And I think you shouldn't build any non-trivial piece of reusable code that doesn't have a sort of plugin system of some type. Everything should be hackable because everyone has different needs, and if you can provide a framework for other people to solve their niche problems, then you don't have to get that feature bloat. So it's a case of, you build tools to solve the problem. So, now I just showed you loads of things, and there's definitely some personal preferences in there, and there's definitely ups and downsides to a lot of the techniques that I showed you, and you are going to need to make your own minds up depending on the particular problem you're creating as what to do. But my main thing is that you really need to think about your API design right up front and design it like you're designing a website. Make sure that it's really usable, it's as simple as it can be, and it's predictable and not making the programmer think about things that they shouldn't do. Make use of the conventions, and lastly, build in some hackability so you're not responsible for all of the niche features. And so we're sort of over time because of my messing around with the display settings, but if there's no time for questions, you can heckle me on Twitter @DanWrong. You can hassle me in the corridor, or better still, talk to me when I'm drunk, because I like arguing about things more that way. And I work for Twitter, and they're hiring, and that kind of thing. There you go.
There are planes, Chris. We didn't have to take a wagon to Oregon.